Okay, so today we're going to look at some index notation. So I just want to go over a couple of things about what these actual parts of a power are. So this whole thing is a power. We actually say this as 2 to the power of 4. Okay, you may hear some people say it slightly differently. There are lots of different ways of saying kind of a similar thing, but that's how I say it and how I wish for us to say it, 2 to the power of 4. And the whole thing is a power. And you have two parts to that. You have this number 2, which we call the base. Okay, the base number. So that is the number that is being raised to a power or a index. So this topic is often called index notation in this case, or indices. So the index is this number, the 4, okay? And we say that as 2 to the power of 4. Okay, then hopefully we know that these index things generally mean that you're going to be timing something by itself a certain amount of time. So 2 to the power of 4 means 2 times 2 times 2 times 2. Okay, and when it is just a number like that, we could work that out if we wanted to. 2 times 2 is 4, times by 2 is 8, times by 2 is 16. So 2 to the power of 4 equals 16. Now what we're going to look at today is just going between something in index form and the expanded version like this. So we're not actually going to worry about working them out. Again, quite a few of the examples we're going to have a look at will involve some algebra. Okay, so we know 2 to the power of 4 is 16. So if we had a to the power of 4, that would just be a times a times a times a. Okay, and then we could repeat the process, whether it's algebra, whether it's a whole number, whether our base is a fraction. Okay, and you might see a fraction put into brackets because we want to make sure that we're doing the whole thing cubed. And the word, when it's a number 3, we actually use the word cubed rather than say to the power of 3, we say cubed. Okay, so that would just be a third times a third times a third. Okay, and again, we could actually work out the value of that just by using our multiplying fractions. Same thing if we had a decimal. If we had 0.4 to the power of 5, that's just going to be 0.4 times 0.4 times 0.4 times 0.4 times 0.4. Okay, so this is just telling us how many times that thing is being multiplied by itself. Okay, and sometimes we might have combination of letters, or we might have numbers and letters. So if we had 2x to the power of 5 all squared, okay, so I'm squaring all of this, which means I'm timesing all of that by itself. I would just get 2x to the power of 5 multiplied by 2x to the power of 5. Okay, and then what we also need to be able to do is go the other way, is potentially have something that's been expanded or multiplied by itself a number of times and put that into index form. Okay, so if we just had m times m times m times m, we can hopefully count up how many m's and realize that that is m to the power of 4. If there was more than one letter, AB times AB times AB, we have the same thing times by itself 3 times, which means it's all of that thing. So we're going to put it in a bracket, cubed. Okay, and then we can we can go again, similar one that would have combination of numbers and letters. 7y to the power of 4 times 7y to the power of 4. We've got the same thing being multiplied by itself. So that is 7y to the power of 4 all squared. Okay, the activity I've got for you is practicing that going both ways, some with numbers, some with letters. Have a go and let me know if you have any problems.